Hello everyone, happy to see you here. Welcome back to my channel Hi Mathematics. Today we have a very interesting equation x squared minus x cubed equal to 12. We need to solve this equation for x, so if you have your solution you can easily solve this question on your own and then write your thoughts in the comments below. We will check our answer, so it will be really interesting. So first of all, let's subtract 12 from both sides. As a result, what we're gonna have? We're gonna have on the left side, we're gonna have x squared minus x cubed and minus 12 is equal to 0. Okay, right now this 12 we can easily express in a lot of ways. Okay, 6 plus 6, 5 plus 7 or different one, but I recommend you to express this 12 as 8 plus 4. And a lot of students might be asking, Mr. why do you think that 8 plus 4 is the best way? How can we express it? But 8 can be written as 2 cubed and 4 can be written as 2 square. And right here on the left side, right here, we have x squared minus x cubed. So we have second power and the third power. So if we express this one as the third power and the second power, then we can easily group it. So right now, let's see how can we manage to do this. So first of all, we have x squared minus x cubed. And as I said before, we're going to express this 12 as 8 plus 4. Okay, so we have minus 8 plus 4 equal to 0. Okay, yeah, we have it. Right now, let's open our parentheses. So we have 8 plus 4 in parentheses, but negative sign before this parenthesis. We need to change all the sign to the opposite one. So we have x squared minus x cubed minus 8 and minus 4 equal to 0. Okay, so I really hope you understand. Of course, we can easily write this expression like that in the next step right here without this parenthesis, but I just want to solve this question step by step because a lot of students can solve this part with a different sign, and this is very bad thing. Right now we solve this question step by step, so I really hope you understand it. Right now this 8 can be written as 2 cubed. As I said before, we need to write it like that. So we have x squared minus x cubed minus 8 can be written as 2 cubed. 4 can be written as 2 square, okay, equal to 0. And as I said before, we can easily group our second power. So we have a to the second x to the second power, and we have 2 to the second power. So we have 2 squares, yeah, and x cubed and 2 cubed right here with 2 lines. I'm going to underline it. I just want to show you this part when we have third powers and second power. Okay, so right now let's group it with parentheses. First of all, let's group our second power. So we have x squared minus 2 square in the first parenthesis. So we have x squared minus 2 square. And this one we're gonna write as well. We're gonna group it as well. So as a result, we have minus x cubed plus 2 cubed equal to 0. So right now, let's look closely. What do we have? We have two parentheses. In the first parenthesis, we have difference of squares. And a lot of students might be thinking, this is something familiar. I know this formula. This is difference of squares. Yeah, when we have, for example, x squared minus y squared. So this is basic school formula, maybe the most popular formula. X squared minus y squared equal to x plus y times x minus y. Yeah, this is our basic formula. And right now, let's look closely. What do we have right here? We have x cubed plus 2 cubed. This is our sum of 2 cubes. So let's remember this. Let's learn this formula as well. So we have x cubed plus y cubed plus y, x cubed plus y cubed equal to. As a result, we have x plus y. This is our school formula, x plus y. And in the second parenthesis, we're going to have x squared minus xy and plus y squared. And right now, let's apply each of these formulas into our expression. We have first parenthesis, difference of squares, second parenthesis, sum of two cubes. So right now, let's apply it. Let's see what will happen. So first of all, difference of squares. So we have x minus 2, x plus 2, x minus 2. We're going to have x plus 2. And in the second parenthesis, we're going to have this one. So we're going to have like x plus 2. So we have x plus 2. And in the second parenthesis, we have x squared minus 2x and plus 4 equal to 0. And right now, let's look closely. After this, after the moment that we expand these expressions in terms of these formulas, we're going to have 4 parentheses. But the main thing, we have the common element. We have x plus 2 and we have x plus 2. So we can easily factor this x plus 2 as a common. So let's do this. So we have x plus 2 right here. So we have x plus 2. And in the second parenthesis, let's write it with this parenthesis. So x minus 2 with parentheses. And minus this one with parentheses, because a lot of students skip this part and then they have a mix with the wrong sign. So this is a very bad thing. Try to solve this question step by step. So minus this expression, so x squared minus 2x and plus 4 equal to 0. Right now, let's simplify by expression on the right side. What do we have? X plus 2, we have the same beginning, x plus 2, and right here what we're going to have? We're going to have x minus 2, so without parentheses, because we have a positive sign. The next thing, minus, but this parenthesis, because of this negative sign, we need to change all the sign to the opposite one. So we have x squared plus 2x and minus 4. Minus 4 equal to 0. Okay, right now let's simplify it. We have x right here, we have minus 2, we have minus 4 right here, so we can use a group of a constant, our variables, with the same power, yeah? So we have x plus 2 right here. In this part, we're gonna write minus x squared in the beginning, just for better understanding, maybe in case this is a quadratic equation. So for this, let's write this minus x squared on the first position. On the next position, let's write expression with x. So we have x plus 2x, we have plus 3x. So plus 3x. And right here we have minus 2, minus 4, we have minus 6. And you know, a lot of students say, okay, right now we can easily solve these two equations, but for better understanding, I just recommend you to multiply both sides by minus 1, because we don't like this negative sign right here in the beginning. A lot of students skip this part, but for better understanding, I recommend you to multiply both sides by minus 1, because then we can need to change all the sign to the opposite one, and we're going to have like the great quadratic equation. So we have x plus 2. This expression, this parenthesis, we're going to multiply it by minus 1, so we have x squared minus 3x and plus 6. And equal to 0, because 0 times minus 1 equal to 0. Okay, and right now at this moment you can easily be proud of yourself that you solved this question on your own. You can easily be proud because you factor it. And right now the final moment, the great moment, because you need to solve these two equations. So the first one, x plus 2 equal to 0. Okay, because a product of two parentheses is equal to 0 when the first parenthesis is equal to 0, or the second one equal to 0. So we're gonna have two equations. This one is the basic linear equation. This one is a quadratic equation, x squared minus 3x and plus 6. We can easily find real quick our x first. From here, x first equal to, we're gonna have like minus 2, yeah, because when we're gonna write this 2 on the right side, so we have minus 2. Yeah, so we have x first equal to minus 2. We're going to check this minus 2 a little bit later. Right now, let's solve this quadratic equation. This is a basic one. Of course, this is up to you. How do you prefer solving this question? I like to solve this question with the basic method. So a equal to 1, b equal to minus 3, and c equal to 6. Okay, with the basic method of coefficients. Right now, real quick, we're gonna find discriminant b squared minus 4ac. As a result, we have b squared minus 3 squared minus 4 times 1 times 6, okay, equal to minus 3 squared equal to 9, minus 4 times 1 times 6 equal to 24. So everything is equal to 9 minus 24 equal to minus 15. And in this branch, in this part, we can easily say that this part we're going to solve with the two complex root, because discriminant is negative. So when discriminant is negative, we can say that we don't have real number roots right here. We're gonna have two complex roots, maybe one, maybe yeah, we have two, because we have a negative 15. Yeah, so we're gonna have two complex root. As a result of our x second and x third, because we have x first, this is our real number root. In this part, we're gonna have two complex roots, so x second and third equal to minus b plus minus square root of discriminant, and all over to a. We know everything, so we can easily plug in these elements into this spot. So we have minus b minus 3 plus minus square root of minus 15, and all over 2 times 1 equal to. Okay, really great. Right now, let's simplify this. Minus 3 equal to 3 plus minus. This square root of 15 we can easily write as square root of minus 1 times 15. So we can easily write this as a product, minus 1 times 15. And right now we can easily split it in terms of basic square root property. Here we can easily write it as, for example, we have square root of a times b. We can write it as square root of a times square root of b. We can easily split it. Of course, it works only with the multiplication and division, not with addition, subtraction. In our case, we have multiplication, so we can easily split it. So as a result, what do we have? 3 plus minus square root of minus 1 times square root of 15, and all over to a. Really great. Square root of minus 1 equal to I. This is our imaginary unit, not like to a. We have 2 right here, yeah? So we have 3 plus minus I square root of 15 over 2. And a lot of students prefer dividing this numerator by 2 just to split it in terms of like a real part and imaginary part. Of course, we can easily write it 3/2 plus minus I square root of 15 over 2. This is up to you. How do you prefer solving this question? This is our real part right here, and this is our imaginary part. This is our x second and x third. So let's write it right here because I don't have enough space on the right side. So we're gonna write it as a final answer. So x second equal to, now we have 3/2 plus I squared 15 over 2, 3/2 plus I square root of 15 over 2, and we have x third equal to 3/2 minus I square root of 15 over 2. So these two roots right here are complex roots, so with imaginary unit. This one is real number root. Okay, so I really hope you understand my solution right now. Let's check it real quick. Let's check our root real quick. Okay, so check. We have x squared minus x cubed equal to 12. Right now let's check real quick over x equal to s of x first equal to minus 2. As a result, what do we have? Minus 2 square minus 2 cube equal to 12. A lot of negative signs, a lot of powers, but minus 2 to the power 2, these are even powers, so it means that this is equal to 4. We have right here odd power, so it means that we still have negative sign because we have minus plus minus plus. It's like jump with the negative power with the even power to the odd power, but in odd power we're gonna have this negative sign, so we have with this minus we're gonna have plus, and 2 cube equal to 8, which is absolutely correct. So our root is really great. And according to a fundamental theorem of algebra, for example, if you know this theorem, I'm gonna say this theorem with very simple words. So just scan what the highest power do you have in your question. In this question, we have third power as the highest one. Yeah, we have the third power. So it means that according to a fundamental theorem of algebra, you're gonna have 3 roots in total. You don't know how many real number roots, how many complex roots, but you're gonna know that we have 3 roots in total. Okay, 2 complex, 1 real, maybe 1 real, 2 complex. So it's like a mix of different combinations. But in our case, we can easily say that we solved this question completely. We have third power, so it means 3 roots in total, and of course our solution is correct. So we can easily prove that our root is also correct in terms of like geometry, in terms of algebra. You know, it's really great to see this question from the theoretical algebra. I mean, that fundamental theorem of algebra from geometric perspective to see this point of intersection, and of course algebraic perspective. This is exactly what I did before. I just solved this question with the algebraic method according to algebra formulas. And after all the things, you can easily say, okay, we solved this question completely according to a fundamental theorem of algebra. It works great. We have 3 roots, 1 real, 2 complex. According to geometric perspective, we have 1 point of intersection. It means that 1 real number root. And according to algebraic perspective, we solved this question absolutely correct because we solved this. It proves different branches. So this perspective proves algebraic one. You know, according to a fundamental theorem of algebra, we have 3 roots, and according to algebraic perspective, we solved this question and we proved that we have 3 roots. Yeah, and according to geometric perspective, we proved that we have 1 real number root. Yeah, you know, this is like a very interesting point of intersection, yeah, from different branches, from theoretical, from geometry, from algebraic. You know, this is really great thing to prove the facts. So I really hope you understand my solution. So write your notes, write your thoughts in the comments below. It will be really interesting to read about it. Also, thank you for watching. Take care of yourself. Have a great day. See you in the next videos.